In this video, we are going to make a homemade Arduino. It functions the same way as the original Arduino does. It's a great project for beginners to make one for themselves as they get more familiar with the hardware structure and learn a bit more about Arduino. Let's get started. Obviously, there are some downside of making a homemade Arduino, like we need an external USB to serial converter, no reset switch, no short circuit protection, no overvoltage protection, and only 5 volts input. But if you know what you're doing, you really don't need that feature. Okay, first let's construct the circuit on the breadboard and then we can move on to the PCB. First we're going to need an Atmega 328P microcontroller which has an Arduino bootloader pre-programmed onto it. Then we need to go to this page and get this Arduino pin mapping image which tells us which pin is which, and it's a great reference for this build. Take a 16 MHz crystal and hook it on pin 9 and 10 of the Atmega 328P. Now we're gonna need two 22 picofarad capacitor. Place one capacitor on pin 8 and 9 and the other capacitor on pin 8 and 10. Pin 8 is ground and pin 7 is 5 volts, so I connect those on their particular rails. Now I'm going to connect a 330 ohm resistor on pin 19 of the Atmega, which is a digital pin 13 of the Arduino, and connect the other end of the resistor to LED's anode, and the LED cathode goes to ground. Now when I give power to the microcontroller, the LED starts blinking, running the standard blink program for the Arduino. Now I want to program this microcontroller to blink the LED a bit faster. To do this, we're gonna need a USB to serial converter or an FTDI module and a 100 nanofarad capacitor. Put one end of the capacitor on pin 1 of the microcontroller, which is the reset pin, and the other end will go to the DTR of the FTDI module. Then connect the TXD of the FTDI module on the RXD of the microcontroller on pin 2. And the RXD of the module to the TXD of the microcontroller on pin 3. Then connect the ground and VCC of the module to the breadboard. Now we can try to upload our modified blink sketch. The RX and TX LED on the FTDI module should light up and we can see the LED blinks at a faster rate. Let's see if we can program this OLED display which works with I2C. If you don't know how to program this display, check out my video about this display. And sure enough, it works like a charm. So now we can move this setup onto a PCB to make it permanent. I took 28 pin base and soldered it to the PCB. Then I added the header pins for breadboarding. Then I soldered the crystal and the capacitors just like I shown in the beginning. It's just like a soldering practice. Just plug your FTDI module and program like normal. Hope you guys found this video interesting, and if you do, hit that like button and consider subscribing to my channel, and also share this video to your friends. If you have any questions, let me know in the comment section below or leave me a suggestion for my next video. Till then, stay safe and I will see you guys in the next video.